In this lab, we're going to look at how temperature and salt solubility are related. So the intro here actually is pretty good, so I'm not just going to rehash it. I'm just going to briefly go over it. So what is solubility? It's the ability for a solid to dissolve in a substance. And I guess it doesn't have to be a solid. It can be any substance that is dissolved in a liquid. And there are a lot of things that determine the solubility of a substance in a liquid, as listed here: temperature, polarity, pressure, size, area. And we're only going to look at one today, that is temperature. Polarity is big. The expression like dissolves like is thrown around all the time. That just means polar substances will dissolve polar substances. Nonpolar will dissolve nonpolar. And you can't mix a polar and a nonpolar substance. Examples being water and oil. Those do not mix. So they are not soluble in each other. And what we're going to do in today's simulation is look at how temperature can affect salt solubility. So what is shown here on the y-axis, we have solubility of our solid, grams per 100 grams of water. Basically, higher numbers mean you're more soluble. And on the x-axis here, we have temperature. And we have 5 different types of salts that are being graphed. And what you can see on this, this chart, this graph, is that there's really no correlation in general between temperature and solubilities of salts. There's no general trend we can say that fits all salts. Some hardly change at all. Some increases a lot. Some decreases. Others have this weird inflection point where you're soluble at some temperature below 100, and then here we just drop off. And so what we're going to do is we're going to look at the solubility of potassium chloride and ammonium chloride today. And the way we do this, it's a very simple classic experiment, is that you're going to take your sample, you're going to heat it up. And then you're going to have salt in there. And this salt will be dissolved. All right, so this salt is dissolved. You then cool your sample until you start to see crystals appear. And you record the temperature at which those crystals first appear, because that's reaching your solubility limit, right? So to be soluble is you don't see any solid. If you have more salt in your solution that's over your solubility limit, some of that salt will crash out or come out of solution in the form of solids. I can show this on this purple chart just as another idea of why this would happen. Let's say that you have 60 grams of sodium HASO4. Do not know the name of that salt off the top of my head, but we are dealing with this purple line. So you have 60 grams of this, right? And you put this 60 grams into 80 degrees of water, right? So we're at 80 degrees. And if we look, the solubility of this salt at 80 degrees is roughly 85 grams of salt. So if we're only putting in 60 grams, all of the salt will dissolve. And so what we would do in this experiment is that we're going to cool the water down. And we're going to cool it down until we see our first crystals. And for this purple line, the solubility of 60 is right here, which is about, let's say, 54 degrees. All right. So at 54 degrees centigrade, you can put 60 grams of the salt, which we did, into water, and it'll still be soluble. if you get any temperature below this, and as long as you're stirring, salt will come out. Salt will crash out below that temperature. And from there, we can say, based on 60 grams of salt, it is soluble at 54 degrees C, because when we go right below that, we see crystals. And so that's what we're going to be doing for salts where we don't know the trend. We're going to figure out, when do we see the solid forming? If you have any questions, please email me or visit my office hours, as the other section will be live today in person. So I won't be able to be on starting at 11 like I was the last couple of weeks. But yeah, don't hesitate to reach out. Even though this is due at midnight, do it early and ask me questions. Yeah, other than that, have a good lab.